All right, asteroids part 2. We were talking about, we think that at one time there was a body probably about 1,000 kilometers across, like Sirius was, in which the metals had sunk down to the core, and then you had the outer region, and then it got impacted with something large, and it broke it into chunks. And the whole thing broke apart. Well, when it broke apart, the core, these became the metal asteroids. And they are pretty much just pure metal. And then the outer part here, these became the stony asteroids, along with the other chunks of rocks that never formed into anything. Most of them are stony asteroids. There are also a lot of carbon type ones, which I'll talk about later. But the cool thing about these metal asteroids, they're very shiny. It's like having a giant chunk of metal miles across up in space. But these are the ones that people think about if you want to make money from space. Because if we got one of these asteroids just a few miles across, it could serve all the metal needs for the whole Earth for like 50 years. Huge amount of metal in there. And not only that, the precious metals in there, the things like gold and platinum and titanium and the stuff that's rare to find on Earth, are in these metal asteroids. And so they estimate that if you get one of these metal asteroids, it would be worth trillions of dollars in US money. Now there's some technological challenges. How do you get a metal asteroid? How do you mine it? How do you get the metals back to Earth? All those things would have to be dealt with. But it may be something in the future that is what would be interesting. Going to the S-type are not that exciting because we have similar rocks to that, and anything that you find there isn't going to be any more beneficial than you get on the Earth. The only good thing about mining space too is that you aren't destroying the Earth. Yeah? All right. Oh, just another tidbit here. There's a mine in Canada where most of the world's nickel comes from, the metal nickel. It comes from one mine in Canada, and the reason it comes from one mine in Canada is we think that millions of years ago a small metal asteroid crashed into Canada, and that metal was left there, and now they're mining it. So it actually came from space. Alright, so here's some pictures here. Oh, before I get to that, carbon type. Carbon type are very dark. They have a layer of carbon on the outside. Remember that there's this carbon dark material that seems to kind of just go through space and gets attached to things. We see that in the rings of the outer planets. Okay? And so these asteroids here have built up this layer of carbon, this thick sooty material on the outside of them, and they're really dark and they're actually hard to see. There's quite a few of them, but they're hard to see because they're very dark. These are very rare, the M-type ones, but they're very bright and shiny. Okay, these are just typical ones here. All right, look at some pictures. This is Gaspra. This is how most asteroids look. There's some kind of random shape. They have impact craters, small impact craters, because over billions of years, objects have been hitting them at different positions, banging them, and they even run into each other. Over billions of years, they can bounce off each other. Doesn't happen very often, but it can happen. This is one of the more interesting ones. This is Ida and Dactyl. When they took pictures of this, I think this was the Cassini mission or the Galileo mission. I'm not sure, can't remember which one. But they decided to fly by Ida, this one right here, and take pictures of it. But when they flew by, they realized it had its own moon. And we thought, oh, you have to be a big object to have a moon. No, you can be a small object. This is only a few miles across, and this is only like 100 meters across. Even a small object can have a small moon if it's just placed in the right orbit around it. And the interesting thing about this, because it's not spherical, it doesn't orbit in a nice elliptical pattern. Because the gravity actually is a line, it actually orbits like this and winds its way back and forth around the object as the whole object goes and spins through space. Very complicated, but now we found other asteroids. We found binary asteroids and asteroids with little moons. Things that we didn't think existed, now we're finding them all over as we start to study them. But that was one of the things that makes this one an interesting one. Phobos and Deimos are asteroids. However, they're not classified as asteroids because they're classified as moons of Mars. Mars has 2 moons, Phobos and Deimos. They're very small. They're not like our moons at all. They're only on the order of like 10 miles across. And this stands for fear and panic, by the way, if you care, for the god of Mars, god of war. But they orbit around Mars, and we think they were just captured asteroids. Small asteroids that got too close to Mars and got captured in its orbit. That's how Mars ended up with these moons. And they're an interesting idea, especially the idea of landing on one of these. If you're trying to land like men on Mars or make colonies on Mars, it's hard to have a ship that goes all the way from the Earth to Mars. So the best way is you have a ship that takes you from Earth into orbit. You change ships. You fly from Earth's orbit or from the moon. You fly to Phobos. You land there, and then you have a separate ship that goes down to the surface of Mars. So it's actually more of a 3-stage trip. Then each rocket can be specialized for its portion of the trip instead of trying to make one giant rocket to do everything. It's one idea. Nobody's really finalized that yet. This is a closer up view of Phobos. You can see there was a large impact here, and not only did the impact come out, but it made these lines of material. Since the material flew out, it made these strings, or rays we call them, that stretched pretty much all the way around the moon. All right, here's some of the ones we have pictures of. These are the bigger ones. 59 kilometers, remember, is about 30 miles across. Okay, so that's a pretty big size. That's Matilda. Eros I'm going to talk about in a second. Gasper was the first one I showed you. This is only on the order of about 10 kilometers across. And then Ida I also showed you. All right, this is Eros. And the interesting thing about Eros, and they're still doing studies right now. They're still sending out spacecraft to these asteroids. In fact, the Japanese sent out 2 different spacecrafts, Hayabusa and Hayabusa 2, that went to an asteroid, grabbed material, and launched itself back to the Earth so they could bring materials back to the Earth. The first one failed, didn't do well. The second one did work, and so we're learning more about asteroids all the time. But the Eros right here, the U.S. sent out a mission called the NEAR mission. This is standard for Near Earth Asteroid Rendezvous. And it went to Eros. And this was one of, just telling you another story here, this is one of the things when things went wrong, but they managed to salvage it. So here's the sun, here's the Earth going around the sun. And then here, so this is the Earth's orbit here. And out here was the orbit of Eros. It's actually exaggerated, it's closer to the Earth than that. But the idea is that they launched it, this NEAR spacecraft, it went around the sun, and actually it passed by Venus in here too. Came around, and then it came out, and it was supposed to go into orbit around Eros and study it for months. Well, the retro rockets that actually have to slow it down to put it into orbit around Eros failed to fire. It was a software glitch. And the NEAR spacecraft flew right on by. So after years of planning and millions of dollars, they missed it. It flew right on by, and it's like, whoop, missed that stop. However, the people at Caltech, which are very good at what they do nowadays, realize that, look, this is going to keep going around the sun, and Eros is going to keep moving around, and if we just let it go in its orbit, we're going to have another shot over here a year and a half later. So everything goes around, everything moves up, and boom, it came back again. They fixed the software glitch, and NEAR spacecraft went into orbit around Eros. So it's one of those, well, we missed the first time, but they made it work the second time. Got lucky on that one. This is what it looks like. It looks like a giant dog boat. And they orbited and took pictures for quite a while, and then they started to run out of fuel. So they said, you know what, let's try to land it on there. It was never designed to land. It was supposed to orbit and just die in orbit. But they're like, well, we're running out of fuel. We got nothing to lose. There's no legs or anything on it. But, you know, they're really good at what they do. So they said, oh, let's see if we can land it on the surface. So this is it. As it lowered itself to the surface, got closer and closer, you could see You can see here there's little pebbles and there's dust. This looks very similar to the surface of the moon, which is what we expected. And this is it when it's about this far, 12 centimeters above the surface of it. This was the last picture it took as it landed on the surface. And you can see the dust and pebbles, very similar to what we see on the moon. All that dust is millions of years of micrometeorites pummeling the surface and essentially turning it into dust, sandblasting it. All right, that's all I have on asteroids.